Okay, now here's a question where we kind of have to remember back to our dynamics unit. A block is moved up a frictionless inclined plane by a force parallel to the plane. At the foot of the incline, the block is moving at 1 meter per second. At the top, 0.85 meters above the lower end, the block is moving 4 meters per second. The block has a mass of 1.2 kilograms. What is the work done? So let's draw a picture. So we have an incline, and a box is being pulled up the incline. I'm going to say that's F at. And now, I'm not really finding too much about force or anything here, but I just like to label that so I know what's going on. And my height here is h is equal to 0.85 meters. I know it says my VI is 1 meter per second, and then a VF is equal to 4 meters per second. So a box is being pulled up, and its speed is changing. So that means we have both EK and gravitational potential energy changing in this question. So we need to consider both when we're calculating W. So overall, we need to think W is equal to delta of EK plus delta of EP, specifically gravitational. Now, if the box starts on the ground, what's its EP? 0. So we're going to assume that the box starts at the ground. So my delta EP is really just my calculated EP, because EP final minus 0 is just going to be EP. So that's only because it's starting on the ground. Okay? Now I'm going to expand this even more and say W is equal to EKF minus EKI added to EP. So you could do all of these as separate calculations if you want to, or you can just have it as one massive. If you do it as all at once, make sure you have a lot of brackets though. I like to do it in a couple of steps at least. I'm going to color coordinate so then you guys can see it a little better. Minus F 1.2 times 1 squared. All added to 1.2 times 1. So I kind of do these each separately. So the first one is 9 joules. Yeah, all of my delta EK. And plus 10.006 joules is equal to 19.0062 joules. So final answer is 19.0.